name is Elena and I'm doing the chapter 10 video assignment. So part A is asking for the mass of iron in grams. So I wrote out the equation right here. It says that iron oxide reacts with excess carbon monoxide, so we know that the iron oxide is the limiting reagent. So we know that the mass of the iron oxide will be the same mass of the carbon dioxide. So the equation gives us everything to solve for the moles of carbon dioxide using the ideal gas law. So we can rearrange the ideal gas law to solve for moles of carbon dioxide. Before we do that, we have to convert the millimeters of mercury into atmospheres, so we can plug it into the ideal gas law. So here's everything plugged in, and then the mass of carbon dioxide equals 0.04589 moles, or not the mass, the moles of carbon dioxide. Anyways, so since we know that the moles of carbon dioxide is moles of iron oxide, we can plug that in and use the moles of iron oxide to get the oxygen, to get the grams of oxygen in the sample. So then we use the total sample of iron oxide and subtract out the oxygen to get the grams of iron, and we get 1.925 grams of iron, and that is the mass of iron in the sample. So for part B, it's asking for the formula of the oxide. So we divide the mass of the iron and the mass of the oxygen by their molecular mass to get the moles of iron, and we use the smaller molar amount and divide that by the bigger one to get a molar ratio, and we get 1.3. And since we need a whole number ratio, we multiply that by 3 and we get iron 304. And then for part C, it's asking for the how many iron and oxygen atoms are present in the unit cell, and they give us 839 picometers. So, and we also get a density, so we can get these picometers into a volume unit by converting the picometers to centimeters and cubing that, and then we use the cube centimeters and the density to get the molecular, or to get the mass of the unit cell. Now that we have the mass of the unit cell, we can use the ratio of moles of each substance in the total sample and multiply that by Avogadro's number to get the number of atoms of each. So the iron atoms comes to 23.975 or 24 iron atoms in the unit cell, and then the oxygen atoms come to 31.9 or 32 oxygen atoms in the unit cell.